of the talks about the nanomaterials and all these things. And next week will be nanomaterial and metal, liquid metal again. So today, Professor Yan Lei will deliver a very nice talk in different, a different topic and in quite different field. So today we have a big, a great panel. So we have the scientists from different part of the world to join this great talk. So before we go to introduce our panelists, first let me introduce our speakers today. Our speakers is Professor Yan Lei. From Peking University, is my colleagues. Actually, I was so lucky as I met Professor Yan like a month ago, or less than a month ago, in another event is our international education event. I heard, listened to Professor Yan Lei's talk about, this is high tech. I was so excited. So I invited him with Professor Yan, can you deliver a talk on iCANX? That's how it works. Today we have this talks. So Professor Yan Lei was in Peking University. He is working in the School of Earth and Space Science, and is a member of the Russian Academy of Natural Science, and also a chairman of expert steering committee of the International Journal of Remote Sensing. He successfully served as a director of Beijing Key Library of Special Information Integration and its engineering applications. And he is a deputy director of academic committee. And Professor Yan has won many, many awards, more than 18 awards. And this most prestigious awards I mentioned here is the second prize of the National Technology Invention and the Geneva International Invention Exhibition Gold Medal. And Professor Yan has published more than 500 research papers and have been cited, many, many thousand kind of times. So I published even more, 10 monographies and books, and his contribution was a benefit many, many, industries, and also inspiring a lot of people. So today we're going to have a Professor Yan to deliver a talk on the optional quantum vector remote sensing mechanism because based on the aerospace means. So Professor Yan, the stage is yours, please. Professor Yan, share your slides, please.
Okay.
Yes. It takes a little bit of time.
This one.
Good. Okay, yeah. So use this time for preparing the the lectures. I'm gonna talk a little bit about the technology aerospace means. Yeah, because Professor Yan has developed a very kind of important technology, to use all these kind of quantum vectors. Okay. Hi, Professor Yan. Are you okay?
Yeah. Okay.
Yeah. Please share the slides.
Okay. Dear everyone, today I give a presentation. The title is Optical Quantum Vector Remote Sensing Mechanism based on aerospace means. I give
Professor
three
Yan, we couldn't see your slides. 您没共享. Okay. Yeah. Okay. Yeah. Please. Okay. Yeah, come.
Okay.
Yeah, that's good. Please.
Yeah, everyone. Today I give my presentation. The title is Optical Quantum Vector Remote Sensing Mechanism based on aerospace means. I talk from three parts. First is how about our related problems. Remote sensing, just related to for our China medium long-term plan of science and technology development have 16 key projects, but 10 related them is especially for Earth observation system. It means remote sensing. Is related to the environment, urbanization, and some things. It means 11 key fields, just 10 related to them. For these parts, one is Earth observation, it means remote sensing. Another is 90% circling economic related to them. For our industry demand, just aviation aerospace data, then serve for geographic mapping information. For our utility bottom, just because much data and many information needs, but we only smaller 3% usable information. It means the information can be utility very little. This reason just because the aviation just is sky field, and the utility just is land field. So this is a word puzzle, just a 2M, 1L. If we want to give results, we can got potential market just 20 trillion renminbi. So the technical questions is reason is what? Just one, just our light just is unbalanced polarized one, but our remote sensing always think this is constant light. So this is the first question, just polarized light. Second is our ground dimensions was instruments dimensions just very different. So this is second question, just a physical gap. The third one just is Custom processing system. Now just always for this way, but real thing just a core global system. So the third problem just is core projections. How about remote sensing? Remote sensing just based on the optical source and then reflected light, and through the sensor instruments to become image products. Finally, based on the image, inverse our land object. But here now, we always based on the these three parts. We doesn't utility molecular. For remote sensing, just based on the line light to cooperation with land object molecular. But how to, based on the molecular to utility our light? This is a quantum one, because our light just is quantum, vibrations, then translate our ground. Then we throw the sensor instruments to got a photoelectron method to finish the photo translating, then obtain the DN, digital numbers. So till now, we should base on our land molecular and our optical quantum ones to stimulate these 4 quantum, molecular, photoelectron, DN means digital number, to finish our high resolutions and more informations ones. So we got 3 parts research. First is basic detection. It means polarized vector with optical quantum and land molecular relationships. Second is technique, just means instruments of land molecular with sensors, photoelectron, DN, obtaining the digital numbers image. The third one just is engineer system. It means got hardware and software online equipment to finish our remote sensing functions. Because the sky just majorly related to optics and the instruments. The land majorly related to geography and geomatics. So we got this kind of research, just sky and land, physical relationships, and cooperation with international friends, including major these 4 parts. So by this way, we obtained polarization industry standard and 3 IEEE standards. Also, our international friends support us to finish this kind of research. Second one, solution and engineering. Question 1, basic detection. Just a polarized vector with optical quantum and land molecular. The question is just for our scalar remote sensing, just have maxi errors is atmosphere near to 30% errors. Another is our ground retrieval level only realize 80%. How to got these questions to got achievements? One is sky polarization field to crack atmospheric error. Second is light, based on the light quantum to reveal ground objects molecular. So this is our first things, just optical quantum vector ones. The theory of sky polarization vector field. This is the sky observation based on the polarization cameras. Then we got a multiple point sensitive sky, got a polarized model diagram. So by this way, we can consider these things just like a field, just from the sun energy. We think gravity field, just a universal gravitation vectors, and the magnetic field, just Earth rotation vectors. So the Earth third field, just the polarized vector field is okay. So based on this, we got space-time variation rule, obtained the sky polarization field results. We also from different place and based on the different seasons, different times to obtain the older world polarizing field results. And also, we just focus on the RS biggest error, atmospheric attenuation from 30% to smaller 3%. Just by this way, we found just a norm central point, nothing can be found, and at some center point, just very clear images, and then we based on the clean air and the pollution air obtained on contact measurement such as PM 2.5 to PM 10. This is what we find air pollution source gas distribution. Before this, we always got air pollution instrument metrics under our ground surface, and very cheap, very high, expensive, and each instrument only 5 years life. But based on the polarized contact measurement, we can overcome all these expensive and also got source gas distribution ones, not just our normal ones, just pollution final, just our particles arrive our ground instrument, then we can found these ones. But that is the results, not source gas and the distribution. And also, we based on this polarized field, we finished the bio navigation instruments, and just based on the animals different polarization directions, the animals' eye have different light. So based on we finish these ones, and also by this way we confirm the field is rules, is definite, can be utility. And based on this, we got scalar images, just one image per shoot. And also, we based on the quantum vector polarized ones, we obtained 9 images per shoot. So by this way, we can more clearly than scalar images. And also, we finished these ones support our China atmospheric satellite series for our CAS to finish the satellite ones. Also, we support 3 to 5 meter resolutions polarization load of solar synchronous orbit for other institute to finish our satellite instruments. And also the stalwart, just our field, very famous world scientists mentioned it. Our work add a new dimension to our understanding of the Earth's environmental radiation field. is an outstanding work. Also, our field, the biggest international society, just photogrammetry and remote sensing. The former, the then chair, Hepker, visiting our university and mentioned it. This is the most advanced theory and technology progress in the field of remote sensing in recent decades. Based on this, we concentrate our ground retriever. We just based on the 20 years, just 2 million data and got 4 ground elements objects and obtained 5 character rules, just including multi-angle physics, multi-spectral chemistry, roughness, density structure, high contrast ratio filter, and on equivalence radiative transfer. Then obtained the polarized ground remote sensing theory. This is especially for third one and fourth one. This is only polarized manner can be obtained our detections manner. And also we set up BPDF module. First got full ground molecular information extracted, and before this just incident conventions ones. And for example, this is 1, this is 0.7, but the into our 3D 0.3 path just cannot be displayment. But based on the polarized ones, it means BPDF, we obtain a light quantum refraction and emergent got real vectors information. By this way, NASA just recommendation our BPDF to replace BRDF just is principal scalar modules. And also from BRDF to BPDF, we got detection of vegetation with CN. Just before this, got a positive correlation with CN. But based on the polarized one, we found that this is negative correlations ones. By this way, Pinus recommendation our results. And also, we utility got seed and nitrogen content monitoring and food secretary ones. Just based on this, for saturation or deficiencies, seed is not suitable. Only moderate seed is perfect seed. And also, we got density and roughness with the rocks relationships. Just the first row, just estimate based on the BPDF, and the third row just is a real example. Their arrows just at 12% ones, and geophysical science tell us by this way can greatly improve our long distance observations. And also by this way, we created 1 to 10 micro precision measurement industry, including fast, super fine concentrating, Chang'e or obstacle avoidation, and also nuclear isolate core cover, fine matching, and high-speed rail precision measurement, and aircraft micro deformation. And based on this, we finished the vector remote sensing benchmark and ground object benchmark and special temporal benchmark books. Also obtained the polarized remote sensing applications standard. Second one is technical link, just lend molecular to sensors photoelectron to obtain digital number, just images, pixels. And the question just first for our scalar remote sensing, just a remote sensing instrument level greatly rely on chip resolution. No way to relate imaging for ground reality, because our remote sensing image always want to reflected ground reality ones, but our instruments only based on the chip resolutions. No way to relate the image for ground reality. The second question is image deviation recognition from ground reality is very, very low. How to overcome these ones? Just a quantum vector remote sensing. First, just a quantum precision of instrument deviation correction of ground object, means based on these formulas got accuracy improvement, dn equal KL 8G. L just means length. The second is no chip method for improving remote sensing instrument through photoelectron sensor from black box to white box. Just for these ones, DN just equal F photoelectron functions, but this is a black box. We should got this for white box. First, we just got a quantum benchmark to calibrate image errors. This is a traditional scalar scalar ones, just our light, just got constant transfer, and this is their performance properties, just wave property, just intensity, frequency, phase, and by this way we got full resolution, including radiation, spectral, spatial, temporal, and we just got single parameters one scene in one image. This is a 1D scalar because the light directions we cannot change it. We only can calculation their values. So this is a scalar one. But real one just is a light quantum dynamics transfer our ground surface. So this is light particle performance just by polarized, just two-dimensional polarized ones to display it. So we got an optical quantum level, just a higher 2 or 3 orders of grid level, because our scalar grid level just need 100 to 1,000 particles cumulated light can be found by our eyes. So if we just got our detection just a quantum level, it means we got then gray levels just 2 or 3 orders. Also, we got full parameters, one scene, more images. So this is a 2D vector and just a vertical, our traditional light directions. So these two together, we can obtain the 3D space vectors. So we mentioned need vector remote sensing. Just first means 2D vector, just a polarization one. But if we together traditional just wave directions, just have 3D space vectors, and just they should these two direction and this one direction has no relationships. So these two dimension and this one dimension can combine together. Based on this, we first got radiations ones, just this benchmark from 10⁻⁴ to 10⁻⁸, because radiations benchmark just is light ones. So our man-made only obtained 10⁻⁴ levels. But for our remote sensing, spectral just 1 byte, and the spatial just 2 byte. This 1 byte plus 2 byte means our radiation need 3 byte resolutions. So 3 byte equal 10⁻⁷. So if we obtain this one's benchmark should be have high level resolutions. So US estimate the moon just have about 10⁻⁸ resolutions, but when they got light to observation, these ones should be very sensitive. Should be very sensitive to find 10⁻⁸ wave ones, but this sensitive got soon saturation. So by this way, they got their light, their the detections not very sensitive, but by this way cannot be detection 10⁻⁸ fluctuation. So they find they go to our labs to discussion these ones. We also based on the polarization ones, just based on the polarized manner, just a low light intensification to realize 10⁻⁸ fluctuations, and strong light weakening to anti-saturations. By this way, we got achievements, and NOAA, National Calibration Center, mentioned it based on the Beijing's polarization one can greatly improve our or be orbit calibration level. And also based on this, we set up UAV remote sensing calibration field, and first obtained just 5 nanometers resolutions, obtained 0.1 to 0.3 nanometers validations once. Higher the resolutions higher than 1 order resolutions. This is the first time. Also, this is based on the polarizations quantum detections manner. And also, we first found spectral radiation and the spatial resolutions. These 3 kind of physical resolutions relationship. Before this, always separate ones. So by this way, we obtained validations level improved 1 or 2 orders. By this way, we, based on the magnetic equations, obtained time, space, spectral, polarization, 2 dimensions, and the radiations resolutions benchmarks. And also, we got space, spectral, and radiations coupling benchmarks. So this is 6 benchmarks results. And also based on this, we obtained the China Patent Excellent Award, and also obtained our Beijing City's Inventions Award. After this, we consider quality control system of image instrument. We, based on this, got many kinds of sensors research and instruments research. Finally, we first obtained 6 elements, just photoelectric parameters, and DN, just a digital number. It means images relationship. For example, ENTA, just a quantum efficiency. Just we obtained the group of images. When we find the best image ones, we definite these parameters. Definite these parameters. Another is GC parameters. Also, we can obtain the best ones images. Then we decide these parameters. By this way, we first finish the new design images, and also we got linkage our ground formula, just first formula DNK LG. L just means land, and this is ground formula. And the second one just is DN and our electronics formulas. Also, we calibrate, we modified them, try to got G arrive at 0, K arrive at 1. It means DN equal L, just our ground real values. So by this way, we got image system errors reduced to 2 orders just by this way. So based on this, we found, for example, our instruments got ground signal errors just 2 orders smaller, And even our chip technology lower than Japan's chips, but combine them together, our ground objects image final precisions still higher than Japan's instrument. It means just based on this, we finished needn't to cheap skills to finish the best precisions. And by this way, we utility our many kinds of satellite instruments and systems, and also we obtained evaluations our education teaching technical development evaluation. Just by this, it means this is the first manner to overcome cheap skills. And also based on this, we obtained a general international exhibition. This obtained a gold medal. This is smaller than third percentage. Just the name is a vector remote sensing image instrument system. This is finished. This just by World in Intellectual Property Organization only host the award in the world, and also the WIPO statistics just 2/3 of the world major inventions received this award. And based on this, we just got 2D polarized vectors plus just our normal ones, just scalar in transmissions directions instruments, finished 3D parametric vectors instruments. By this way, we finished the 3 books. Just one is optical quantum vector remote sensing benchmark. Another 2 just is opto electronic image control benchmarks. Also, we obtained polarized vector remote sensing IEEE standard. And Kevin also is our this standard vice chair. The third one, just engineering system, just finish the formal 2 things. Then we got hardware and software online system. The problem just no digital aero remote sensing system before. When we focus on these ones, just this sentence beginning. Another is no real-time high-precision processing system with a consistent coordinate system. And we, based on the UAV remote sensing system with high precision and minimized hardware, and also got emergency rescue system with polar vector real-time processing software. First, we just set up their classifications and the physical module and the radiation transmissions formulas and attentions systems. Finally, we got the light, the density just reduced 1 order, optical collimations 2 orders, and the volume weight just smaller one orders. Based on this, we finished UAV remote sensing system first flying ceremony in China, and also finished Death Carrier Jinsha River. Its wingspan just 12 meters. The height change just 6 meters, 600 meters. Carrier wide, just only 35 smaller. The flight time just big 10 hours. By this way, we also got our China Education Ministry Award, just scientific and technology innovation. And also based on this, we set up this kind of industrial systems and got their research time, general people, guarantee personal and continual time, and economic efficiency. All these got greater achievements. So by this way, we set up UAV Industry Alliance and the Innovation Industry Alliance, and finish it from a leap 300 human aviation system to 3 millions UAV remote sensing systems, and also finish it just ecology monitoring based on the satellite to transfer just our UAV remote sensing just from 10 to 20 days to 1 day, and also got a flood monitoring just before, just half days to 1 days. Got data updated to now, just 1 hour is enough. And also we got Homeland Security experiments. Before this, we have no available technology, but now we finish the real-time ones. Just based on this, we consider how processing our remote sensing images. First, just for a long time, just for the car system, but we obtained our information just from our Earth, just latitude and longitude. And finally, we got a digital Earth, also should become latitude and longitude ones. But our processing is just based on the car system. So we got near to 7 times coordinate transfer. By this way, we got 20% time wasted for this one. Also, just with utility computer, so have cut errors, cut length errors. So this is also got very difficult things. And another thing just is for our arrows and satellite ones, just our altitude greatly bigger than our plane XY. So just we got their relative value, just delta Z minus Z, greatly smaller delta X minus X, just this one. So this got our matrix just O1, just this got our normal ones. Also, we got these ones become cannot be finished our processing. So if we want to transfer these ones, we should got z and xy just not same same dimensions. So we got call for conformations based on the polar coordinate system to achieve it unit with data acquisition, processing, expression, organization, and management. So this is our consideration. And based on this, we also found polar ones system just is in the dependent system, but Descartes just is a dependent system. It means x, y, z just is raw theta phi's functions. So if we want to change, for example, x arrows, real things, just we change just polar parameters raw theta phi. Finish these ones, our x arrows reduced, but raw theta phi also changed. So this got xy changed. So got these arrows added. So it means only polar just is independent system, but XYZ just is dependent system. It's interrelated. So we utility polar ones. We got XY just a polar angle and Z just a polar radius. By this way, different dimensions eliminate the circulated the normal equations. So after this, we obtained our accuracy 1 order raised and the efficiency 1 to 3 orders raised, and also robustness just 2-3 orders raised. So this is our achievements. The international ones just we find the best results, and our results we just try to find the worth it ones. By this way, we still obtained 1 or 2 order, and 2 or 3 orders accuracy, efficiency, and robustness achievements. And after this, we set up our software, and we found just for the very smaller angle for Descartes system, just is not not the divergence. And also we got just Descartes polar system. This got guarantee vector convergence. So this is our theories confirmed. And based on this, we utility for Yunnan earthquake rescue system. Our software derivation of collapse estimation from 200% errors reduced 20% ones. By this way, we improve the life rescue conditions, and then we, based on this, take part international rescue, just Nepal earthquake ones. And by this way, we first got international rescue and command decisions. By this way, we finished our parties information equations from 0 to 1 achievements. And based on this, we got nature disaster rescue industrialization, and also serve for policy urgency survey the informatizations. And by this way, we got our software to display it international, just at open source 10 years to accept international to use them. And also we obtained general international exhibition invention special gold prize. This percentage is smaller than 1 percentage. And the jury president announced it as the only universe grant prize in recent years. And finally, we obtained the light core vector processing benchmark book and the vector remote sensing process control benchmarks. And also we obtained IEEE international standard. One is polar coordinate system. Another is UAV application universal framework. The third, new progress and summary. First, we got important remote sensing precise control and the intelligent system constructions. Give a conclusion for remote sensing, vector remote sensing for 7 key technologies, 9 difficult host spot, and 5 intelligent tasks. And also we just obtained the 4 standard, finished the vector remote sensing engineering achievements. And finally, we got relative effect verification of optical wave field accuracy limiter, because this we can found the final hour light precisions, how is their final ones. Also, this got some achievements. And we got active and passive remote sensing method comparisons, just based on the optical polarization and polarization sum. Also, we expand the new theory of information security, just utility polar coordinate processing ones to satellite ones. The achievements higher than NASA and Europe normal working system database. And also we got 10 books and 3 first international special issue for vector remote sensing. And finally, we got ground rectification traditions, 70 years remote sensing histories changed, just set up real light source polarization benchmark. And also we break restrict area, just 40 years aerospace history to set up geoscience sensor parameters. And also we change processing method. This is 170 years photogrammetry history, finished polar coordinate dynamic benchmarks. So this is just focus on the quantifications, automation, and real-time. Combine them, we can welcome our remote sensing's intellectualization's future. Also, we obtained some economic results. And finally, our China set up remote sensing's specialty field. Just by this way, we our China official announce just got interdisciplinary subjects, just remote sensing one. Okay, my finishing my presentation. Thanks everyone.
Yeah, great talk, Professor Yan. Let's take about 60 minutes. You give a brilliant story about this heterogeneity, high resolution imaging system. It covers such a big, kind of knowledge and so many exciting technologies. So let me introduce our panelists, and we got to the panel discussions. And okay, today we have a great panel. Yeah, first, let me introduce our panelists. Our first panelist is Kevin Tansey, as a professor and remote sensing and Earth observation at University of Leicester in the UK, Leicester City. Famous soccer teams. So great, as also the editor-in-chief of International Journal of Remote Sensing, and is a member of IEEE and the UK's RSPSOC. He has led more than 50 research projects. It's a lot. You still have a lot of funding. And its research interests are in the remote sensing of the land surface, and especially interested in the wildfire mapping. Wow, agriculture yield estimation and characterizations. So is interested in using our machine learning and deep learning algorithm to process large and complex data sets. That's great. We are so grateful to have Professor Kevin Tansey here. Our next panel is Oliver Dobovik from the University of Lille, France. Professor Oblig is a professor especially in the retrieval of aerosol properties from the satellite, ground-based and airborne remote sensing observation. Received a PhD from Institute of Physics in Minsk. And he then worked in Japan, for 2 years, and then, go to France, leading the research institute of the Laboratory of Optical Atmosphere. Yeah, so is also the director for CNRS, research director. Professor Dubovik focuses on the refinement of the methodological aspect of numerical, invention for the needs of remote sensing by applied elaborated stylistic optician approach. He developed, the open source algorithm. So I think this was very popular, for the people's, for the diversion observation, including both positive and active observation from satellite and ground. So this is great. Let's welcome Professor Oblig. So we have another panelist is from China, as Professor Zheng Qiangli, is a professor in the Aerospace Information Research Institute from Chinese Academy of Science. Professor Lei is also a member of international radiation, commissions, and Secretary General of the Committee of Environmental Information System and Remote Sensing of CSEC. His research activities concerns remote sensing, of the environment and the studies of atmosphere, ozone, and the pollution, polarimetry observation, and atmosphere correction for the Earth observation of satellites. He's a founder of Chinese Sun and Sky Radiation Meter Observation Network. How nice it is! Yeah, it won many awards, and I also, authored many papers. So welcome, Professor Zhengqiang Li. Today our challenge is Shang Ke. Yeah, he's a PhD student candidate and the School of Earth of Space Science in Peking University. Her research interest covers ground penetration radar, navigation and control, and the intelligent traffic system. So this is really a great panel. So we go to our panel discussion. So as usual, we invited our challenger to ask the question first. Shanke, are you ready?
Yes, of course. Thank you, Professor Zhang. Let's firstly let me show my thanks to Professor Yan for his nice and impressive presentation. And I have only one question. I wonder what is the main difference between vector and scalar remote sensing? And could you please tell us, Professor Yan?
Professor Yan,
what is the main difference between vector and scalar remote sensing?
Just for scalar, just only utility the light directions parameters. The vector just based on the light quantums, the vibrations transfer to our ground. So the different, just we got high resolutions ones from only line, just a constant value return to quantum resolutions ones. So this has 2 or 3 orders resolutions raise. This is the first thing. And the second thing just is our remote sensing just have 3 parts. One is ground retriever. How to ground retriever should be detection our ground molecular. Then we can obtain all the our ground details. But how resolutions, how length compare with molecular, just our light quantum. So if we want to got a real retriever, our ground ones should be stimulate quantum stimulate our surface molecular together. This also our sensor and the instruments just finished electron optical to electron ones. Also, these just particles levels. If we doesn't utility our light quantum ones, we cannot got optical electronic levels resolutions ones. Also, finally, we just obtain the images. If we want 1 by 1 each pixels to calculations to utility, we also should be link with them together just at light quantum levels. So light quantum just link with remote sensing ground instruments and the images together. Before this, we doesn't utility. So these three paths always serve itself very well, but finally cannot be obtained our remote sensing ground retrieval final results, good results.
Okay,
Does this answer your question?
Thank you. Thank you, Professor Yan. I believe that your talk helps us to understand vector remote sensing better, and I believe it will get more and more important in our research field. So how about give back to Professor Zhang? Thank you.
Okay, it's a nice, yeah. Okay, yeah, let's move to our panelists. Yeah, so maybe Kevin, you go the first.
Okay, well, thank you very much for hosting this interesting talk, and to Professor Yan for his good overview of polarimetric remote sensing. So I guess my questions is to how to get, as educators of future generations, and I can see the number of master's students that you've taught and have internationalized their experience as well. How do we get more of this type of data in front of students and researchers and early career academics, so they can try and understand some of its information content? And so that's the first question. How do we make more of this data available for the research community? Professor Yan.
Hi, Professor Yan. Yeah, the questions.
Okay. Yeah. The data just from polarization instruments. Before this, we obtained 0.3 million data to do this one. Certainly, this is based on the major is based on our outside detections, and part of them maybe 1/3 just is aviation's ones. So also just for satellite, we know just our air pollution detections and weather forecast, just also based on the polarization manner, but the resolutions are very low, near to 1 kilometers resolutions, cannot be exactly obtained our ground targets, only for flood and weather detections. But based on our technical achievements, certainly now we just got aviation's polarization instruments. Also, if we combine our polarization parts together, our normal, for example, our optical instruments and other kind of, for example, laser instruments together, just become polarization color instruments, polarization laser instruments. So by this way, we can easily to obtain the data, and also to got our field, including students and researchers, to got this kind of work. Okay?
Thank you very much. I'll pass on to another panel member. Thank you, Professor Yan.
Okay, good. So can we move to Oleg?
Yeah, it was very interesting presentation. Thank you very much. But maybe I'm a little bit out of field, but I think if you could give a little bit more clarification, I mean, to understand the subject for me, and I'm sure for other listeners, and if you could give a few precision, for example, when you're talking about remote sensing, polarimetric remote sensing, which spectral range do you talking about? What kind of geometry of measurements? For example, I'm working multi-angular polarimetry, if it's with monoviewing observation or multi-angular, and also very interesting for me to understand what kind of parameter you try to characterize, what kind of components. Is it land surface, bidirectional reflectance of land surface, which resolution, or maybe it's like me, I'm studying atmospheric aerosol or clouds, and what kind of particular instruments are you referenced to? And also, of course, it would be nice to emphasize what actually polarimetry adds to the pure intensity observation in that respect.
Okay, thanks. We just first we based on the powder some data to analyze this our targets, and also certainly because polarization ones just have multiple angles to detections our targets. Also big angles to with 14 angles to do these ones. And also for example, we just got agriculture seed detections. We just detections is nitrogen and the carbon ones to the distinguish best or normal or bad seeds. And we got including some rich nutrition, our oceans, animals, some things.
Okay, yeah, it's cool, but this is really a large, kind of topic. So it covers many parameters. Yeah. Okay, so Alec, any other questions?
No, thank you very much. I think other panelists should have time to ask us. Thank you.
Okay, yeah, Zheng Qiang there waiting. Okay, Zheng Qiang.
Okay, thanks, Professor Yan, gives this interesting talk, and congratulations for your achievements. I'm come from Aerospace Research Institute, so satellite institute. I'm very interesting to your idea and propose for using the neutral point of atmosphere. For example, another thing you propose, use this atmosphere window to look through the atmosphere and see more clear the surface. So can you explain more on these interesting points? And my question is, first, how is the possibility satellites can find this window from space? I mean, geolocationally, maybe in some special region of the world, you can find this. Second, what's the advantage and limits of this neutral point observation? For third, my question is, when you expect the satellite can perform such kind of observation? to improve the remote sensing accuracy?
First one, just a central point, just near to sun into. So we got this kind of aviation experiments just about 30 kilometers radius circle period. So for these ones, it's enough for our detections, our interest in ground scenes. And if we got satellite, should be designed same orbit satellite. So by this way, always just our observation at neutral point. Why neutral point can easily to obtain our ground targets, because just at this period, just into light, just face atmosphere, but no ground information. But its reflections, return line light, just including atmosphere ones and ground information together. So we just add them together, in and outside together. Just we can overcome aviation. Overcome the atmosphere effect. Only ground information obtained. So we finished these experiments, got very good achievements, and almost our ground polarized information almost poorly obtained. And you ask the third one is what?
Because you mentioned you have made some experimental test. My question is, at what time, when you expect the satellites can use this neutral point to improve the remote sensing, current remote sensing?
Oh, this is based on the most of our remote sensing, especially polarization remote sensing scientists together to do much more real things. And also, I think first we can base it on the aviations want to do some things. Got our instrument, just a neutral point instrument, much more better. By this way, to let our government and some department to support to do these ones. I think certainly these situations can be changed.
That's amazing. Thank you.
Okay, that's
thanks.
great. Yeah. So this is my first time hear the story about remote sensing. So I have a lot of questions actually for our panelists. So I'm so curious about this. Okay. So I take the advantage to be moderator to ask some questions to our panelists. So Kevin, so I see you, interested and you work with, especially you're interested in the wide fire mapping. So we all know that for the Hawaii one, the wildfire, that was so a disaster. So can you talk about how you do this kind of mapping for the wildfire? So for this remote sensing, yeah. So the comments on that.
Thank you for that. Thank you for that question. So I think my form of remote sensing is more utilizing generic data sets that are provided by the United States, NASA, European Space Agency. Also, we were very keen to work with data sets provided now from China, because China is launching a lot of environmental data sets. And we use combinations of data to understand the dynamics of the vegetation surface. I think these observations of the surface at different angles, at different polarizations, and at different spectral wavelengths are very important, because the dynamics of vegetation in a warming climate can be quite revealing and interesting to understand the responses of the natural environment, and then also how humans are interacting and living within that within those environments to manage the vegetation canopy. So we look at the severity of the fire. We look at the loss of vegetation. You also look at the ignition sources of those fires, and also the amount of carbon that's been consumed. So in fact, a wildfire really helps to understand the dynamics between the atmosphere, the atmospheric chemistry, the atmospheric physics, and the land surface dynamics, and that's what we're interested in, and that's what we're going to be looking at for the future, hopefully in collaboration with our colleagues in China and around the world. Thank you.
Okay, that's great, because that kind of disaster was to get to the whole world's attention. So I saw that you research on that. I have another question. Okay, I have another question is for Oliver. So Oliver, yeah, I saw you got school was for the Institute of Physics, but now you are most famous for all these kind of remote sensing algorithm. It's this kind of open source stuff. So where did you got the mathematics training? So did you always ask the students can not only have the physics, also training in the mathematics for this kind of research? You mute, Professor Alex.
Sorry, the physics, especially theoretical physics, heavily relied on mathematics, and I was kind of tend to really be interested in this theoretical physics and therefore mathematical background, and this is why although I was an Institute of Physics, I really what I did. It's looked more like mathematics, and once I started, I was keep doing that for all my life. So, and like for example, I do inversion algorithms, and the inversion by itself doesn't relate to any mathematics. I mean, you can take any different application, and still you have to realize inversion, and that's how it can connect one to each other. I hope it was clear.
Now I understand why I didn't touch for the remote sensing, because I'm not good at the mathematics. Yeah, also far from that. So next time if students want to get to the remote sensing field, I should answer or go first. Learn physics and then learn mathematics. So you're good at that. Let's go ahead. Okay. Yeah. So, okay, yeah, we were still maybe the last, the last question, because I'm so curious about this. So, Zheng Qiang, yeah, Professor Li, what's the meaning for that Chinese Sun and Sky Radiation Observation Network? Is this was a open network for all these funds, or is it for professional people to do something? No, Sun, Sky.
No. It's not pure scientific instruments, because this is kind of also atmospheric research instrument. Its measurements directly related to air quality. So from the data we can see, okay, today is a polluted day, or tomorrow it is a clean day. So sun and sky means it use sun and skylight as light source. So it's a standard remote sensing instruments in the ground, and we organize it as a network across China. So it's hard work, but it's useful.
Okay, great.
you.
Yeah. So yeah, thanks for everyone, answer so many questions from me. Yeah, because I was really, really curious about all these kind of, topics. I think it's, remote sensing is really a big topic in the public, but no one knows what things behind, Yeah, they all know that this high resolution imaging from, a satellite or somewhere. They all know that forecast about all this as weathers or atmospheres, all these things, but we all don't know, where the data came from. Now today, Professor Yan and all of you answer some of the questions, for where it really from. So yeah, it's a great kind of, start, because today we open this field, we got to know so many people on the world was working together, to answer all these questions and, to do all these works. Thank you all of you so much. So iCANX is our open platform. Yeah, I think we're going to hear more about all these stories. I think we invited all of you to, deliver talk on iCANX in the future, because this will, got more attractions to the students and the young generations, to know what we really can, this world are really working on and how it works. So thank you all of you, and time fly, 30 minutes is going so fast. Let me to conclude all today's work, and thank you all panelists and the challengers and our speakers. So Professor Yan, this was a certification for you. So I'm so honored, to deliver this to you. So, and I hope I met you in the campus. I will give you a paper of this. Yeah. So, and welcome all other panelists to deliver talks on iCANX. Yeah, we really really excited to hear all these kind of talks. And next week, we're going to have speakers from University of North Carolina State University, Professor Michael Dickey. He's going to talk about the liquid metal for the soft and stretchable devices. So yeah, if you are interested in this technology, welcome you come back to iCANX. And thank you all of you. That's all for today. And hope you have a great day, and hope you, continue follow iCANX talks every Friday, same time, same channel. Thank you so much.